Hello everyone. In this video, I'll be explaining about how does gravity affect the space and time around us. So what is gravity first? Gravity is like a magnet with some force. There is the gravitational force which protects some attraction towards any heavenly objects. If this is Earth, then the Earth also has some gravitational field. There is a magnetic field around it, and its gravity attracts Moon, and Moon again attracts Earth. As Moon also has a mass, it will also have some gravity, and the distance between them will produce the amount of gravity and the force needed. So we just saw that gravity is like a magnet. This magnet has some attraction force and all that. So how does this magnet, this gravity, affect the space and time around us? So now I'm going to explain how does gravity affect space and time. First, space is like a fabric. It's like a piece of cloth. And on the piece of cloth, there are many points where there is so much stones around. Just try this activity. If just put a cloth, not on the ground, on the lap, then put some stones around. Just some weight, not only stones, some weight. Then the cloth will be coming down because of the weight of the stone or object. This is the same case on this gravity. Gravity is also like a fabric, and there is some weight here. And this weight is the gravity. And the gravity acts some force on space. There is the fabric. And this gravity, there is a space fabric, just turns down. It falls down because of the stone. There is the gravity. So how will space or the time would be look like gravity? If this scenario is with gravity, and if there's no gravity, then space fabric would be just a straight line. This straight line means that there will be no time taking place, meaning that everything will be standing still. So as I told you, the gravity is just like this. This is the space, which is space fabric. And then here is Earth, which is also a ball, or we can say it is the stone, which acts the weight due to gravity. So that the space fabric just bends. The gravitational field of any object will be bending the space fabric. So now, with this we can understand that more the gravitational force, let's say this is Gf, this is G force, will be equal to more the bend, that is B, the bend of the space fabric. So we can conclude that if there is more gravitational force, then there will be more bend of the space fabric, meaning that if you go to a more gravitational forced area, then the time around you, time with you will be moving really slow. So what will happen in the case of this sun? Sun is actually really bigger than our Earth, so that if we go near a sun, let's say we are here and our Earth is around here, which is a blue planet, then there would be a full space continuum, meaning that we can see our Earth moving faster from this point. There will be a huge distance gap from here, and we can see that the Earth will be moving really faster than we thought. So the gravity around sun will make our time around us, move very slow, and the time above us, meaning that the time on Earth, let's say this is T1 and T2. The T2, that is the time of ours, will be really moving slow. The T1, the time on Earth, will be normal, meaning that we feel that is normal. We can see that people aging older and older. So there is a really rare sight to see. But what will happen if we went near a black hole? Now let's assume that this is a black hole. This line, let's say this will be a black hole, this round thing. So what will happen is that the black hole will be having a really high gravitational force, and it is believed that even the light cannot escape the gravitational force of a black hole. So some theory states that if you're this close, that is you're near the horizon of a black hole. They call this edge of the study of the black hole as horizon. If you're near this horizon of the black hole, you can see the end of the universe yourself. So this means that the time around you when you are near the horizon of a black hole, the time moves really super slow around you. Meaning that the time around you, there's a universe time, will be moving really normally, meaning that it will seem really fast. That in a speck of a dust, you can see the universe ending yourself. From this, you can again understand that gravitational force, when it is bigger, the more the gravitational force, more the time taken. So, and the bending of the surface of the space fabric. I hope you enjoyed the video and thanks for watching.